Our first speaker is Dr. Rich Radke, a professor of electrical, computer, and systems engineering. It's a department in the School of Engineering. Rich's research focuses on computer vision and machine learning to create occupant-aware environments. Occupant-aware environments. His talk today is entitled Computational Creativity. I saw his slides earlier. There's not one word on any slide. No equations either. No equations either. Unless he changed them between yesterday and today, but okay. His talk will focus on advanced technology and how algorithms have shaped creative endeavor and the evolution of today's generative artificial intelligence, also known as AI, algorithms for creating images, text, and video. Please join me in welcoming RPI's own Professor Rich Radke.
All right, hi everyone. So my name is Rich Radke and I'm from the ECSE department here. And so what I'm going to talk about today is basically, I call it computational creativity, which broadly speaking is how technological advancements have enabled humans to create and augment their creativity. And so this ranges from the days before there were actually even computers to the days today where you can pull out your phone and basically create an image of whatever you want. And so, of course, human creativity is like a huge endeavor, and so I'm not going to talk at all about how, for example, technology has affected recorded music, which is a huge topic, or how it's affected cinema. I'm going to kind of focus my attention on images and videos, like you might see at a museum. And so a good place to start with that is an artist named Sol LeWitt. And so this was an artist who was well known in the 1960s for not painting his own work, but instead basically providing a recipe or an algorithm, if you will, for how these works should be created, right? So he would specify, okay, you want to draw 50 squares, they should be in this random assortment of colors, in this order, and then someone else would go out and paint it. And so actually, if you go to Mass MoCA, which is a beautiful art museum, it's about an hour east of here, a beautiful drive in the fall through the Berkshires, it would be good to do as a day trip from here. There's a huge multi-wing exhibit of Sol LeWitt paintings, which is a great resource, and so I encourage you to go take a look at that. Kind of closer to engineering is this architect in the 50s, Ben Leposky, who he was playing with an oscilloscope, and he decided that he could take pictures of these kind of colored spiral images, and these were actually exhibited in museums in the 50s. And of course, when the digital computer came around, then we had places like Bell Labs and other university type places that were starting to work with these new devices. And so Bell Labs was a very forward-thinking place, and they hired an in-house artist named Lillian Schwartz to investigate how these new tools could be used to create art and creative output instead of just using them to solve PDEs and linear algebra problems. And then artists started to realize that you could, learn a programming language and then create new forms of art. And so, for example, in the 70s, there was an artist named Vera Molnar who taught herself Fortran and then began to generate these kind of procedurally generated grids of squares, for example. And kind of the highlight of this era was an artist named Harold Cohen, who in the 1980s designed rules for drawing and painting and filling in different kinds of objects like people and flowers and plants and so on. And he hooked this system up to plotter paper and paints, and he was able to basically press the start button and you wouldn't know what would come out because of the randomness in the algorithm. This was, again, retrospective of his work was just at the Whitney a few years ago, and so a very well-known kind of, I wouldn't call him a digital artist, but certainly a computer artist. So taking it back a little bit more towards university level research, this is work from the late 90s, and so the idea here is people were very interested in what was called non-photorealistic rendering. So how can you take a photograph and make it appear like it's a painting of some sort, right? And so what's happening in this early algorithm is that the algorithm is laying down strokes of kind of coarse to fine paint to make some output that resembles something that you might have imagined came out of an artist. Of course, it's not, it's still very similar to a photograph, but that kind of kicked off a whole bunch of interesting research on making photographs and turning them into painting type things. And that generalized to doing it to video. So the idea is that you want to lay brushstrokes down on top of video, and you got to make sure that those brushstrokes are kind of staying stuck to the objects that they're on so they don't seem to wiggle around too much. Of course, then we had the era of deep learning and neural networks, and so that enabled a whole different kind of work on what was called style transfer, where again, you provide an input image, which is the content, and you provide some source image, which is called the style, and then you can make these new images in different styles, basically with a push of a button. And this generalizes now to 3D scenes. So you can go out with your phone and you can, take a bunch of pictures of an environment as well as a source kind of more art image, and then you can create an output that looks like a kind of fanciful tour through this three-dimensional scene. And so this is an algorithm that is called neural radiance fields combined with some other stuff. Now, related to this idea is kind of what you think of as like a kind of a paint by numbers, right? So the user provides kind of a color map of saying, I want to have some forest here and some mountains here and some water here, and then the algorithm generates a pretty photorealistic result that never came from a camera but looks like what you specified, right? Again, the advancement of this is something more like you provide a style, which is I want it to look like a sunset, or I want it to look like a forest scene. And then you provide the content, which is the paint by numbers kind of color map at the top. And then you use a big neural network to generate a pretty realistic looking image. All of this type of work is enabled under the hood by what are called GANs, generative adversarial networks. And so GANs are a tool that researchers designed in order to understand how to make better and better, more and more realistic versions of some certain class of images, in this case, human faces. And so in the beginning, these images wouldn't have fooled anybody. They looked like kind of blurry, noisy, bad passport photos. Now, you can make images that are virtually indistinguishable from the real thing. And so here's an example of kind of a random walk through the space of one of these generative networks that shows that you really can't trust any picture of a person that you see online anymore, because these are all totally fake people. And this was 5 years ago. And so you can generate people of all ages and people with dark hair and light hair and glasses and ponytails and stuff. So it's pretty mesmerizing to kind of look at this looping set of images of people that all look pretty real but never existed. And so kind of bringing it back to art, some artists realized that we could use this kind of generative technology to make new forms of artworks. And so this is a GAN artist that I like a lot named Sofia Crespo, who basically curates her her training data set of things that are like really highly saturated, birds and jellyfish and flowers and so on, and produces very evocative, very cool looking outputs. For example, here's like a page from a manuscript that never existed of a bunch of animals that never existed, and it still looks somehow like mysterious and fantastic and realistic, but it's totally generated. Along the same line of that kind of paint by numbers is this example of an artist who hooked everything up to a webcam, and then just by moving stuff around on your desktop, you can make your fabric turn into crashing waves, or you can make your phone charger turn into a volcano. Let's see, why can't I click on this? Oh, I can't move it. There we go. So like this, different kind of thing, just by clicking a switch, you can change, your hands into flowers and so on. This is kind of like, again, the democratization of tools that were developed in universities and research labs that are really very complicated, that now people are just like pulling off the shelf and using to make new things. And this kind of hit the ceiling a few years ago when a group of French artists used a GAN to create this kind of portrait-looking object that then sold for more than $400,000 at auction at Christie's. It raised a lot of questions about how is this piece authored and who really owns it? And they were very cheeky. They kind of signed the piece with the equation that governs the generation of the image, right? So this really generated a lot of buzz and interest in the art world. And now things have gotten mainstream a little bit. So here, you can go to the Museum of Modern Art in New York. They gave an artist studio basically permission to use their entire digital archive, and then the artist studio used that to make this kind of ever-shifting, display that you can see. It's like a shrine. People are standing in front of it like they're awed, and you can kind of see this ever-morphing set of images that, again, nothing is coming from their collection, but it's all kind of inspired by their collection, generated by their collection. So we think of, also things like Photoshop, right? So I just wanted to say that, Photoshop, while it seems like a 20th century thing, has actually been around for a long time. So here we basically have a picture of General Grant on his horse, except it's actually a composite of 3 different pictures. Someone who's not Grant on a horse, the head of Grant and some other background, right? This was in 1864, not long after photography was even invented, right? So people have been thinking about this for a long time. Things like what's called in-painting, removing an object that you don't want from the scene. This is from the 1930s, someone didn't want this guy on the right in the picture, and so someone had to work hard to replace him with realistic looking texture. This is all definitely pre-computer for sure. Of course, now the modern version of that is on your phone. There's something you don't like on your image, you swipe your finger over it, and that is removed or deleted, and even now replaced by something that you describe. So you could say, okay, I want my dog to be happy, and then it replaces it with a happy dog face. Or if you have an object that the generative model doesn't even know about, like this cat sculpture that your kid made in kindergarten, you could take a dozen pictures of this cat sculpture and teach the model just about that new thing, and now you can have Steve Jobs holding the cat sculpture or that cat sculpture on the moon, for example. One thing that's made a lot of waves in recent years is this algorithm called ControlNet, where the idea is that you provide as input some sort of a controlling feature, for example, like a flat image, like the Starbucks logo, and you turn that into a photorealistic looking image. And so again, this is research code that now people are using to make all sorts of things on the internet. For example, here, this super cool looking robot, if you squint your eyes, you should be able to tell that it's kind of trying to get you to watch my YouTube videos. And so if you really squint, you should be able to see the black and white text. Works better, depending on what distance you're from. Anyway, so the guiding field here is this black text on a white background, and then there's a robot that's kind of laid on top of it. And so now you see people doing things like making Pixar avatars of themselves, or turning their dog into Nicolas Cage, and things like this, right? So you can find a lot of interesting stuff on YouTube, right? So this is a visual effects company that has a channel that puts out new videos every week. And so these guys, again, are using research code that was developed by universities. They took a lot of pictures of themselves in very kind of striking, exaggerated positions, and then they trained generative AI algorithms to create these kind of like anime-looking, super exaggerated things. This is just the behind-the-scenes version of it. You can find the whole video on their YouTube channel. Another kind of thing along this line is blank by Balenciaga. And so here, this is Harry Potter by Balenciaga, where you kind of specify a text prompt that describes the character, you describe some sort of high couture, thing that they're wearing, and there's some other stuff that makes their head turn and their eyes blink, and so you can find all this sort of like, whatever, Star Wars by Balenciaga and so on. So it's kind of fun to look at that. This is a person who is not a big name. She's just a artist in San Francisco who has a friend and a phone, and she's using this off-the-shelf neural radiance field code to make these very cool algorithms, or these cool videos that she can then put on Instagram and teach people how to do, right? So it's like, I don't have a fancy camera, here's how you do it. Follow my project, follow my channel, and I'll tell you how to do it with code that you can download off of GitHub. So again, this is the kind of thing that would have been very difficult to do in a research lab even like 5 years ago that now is possible to do on your own. And so bring it back to what am I talking about this at RPI for? So I teach some classes that are related to these kinds of ideas, and it's very satisfying to take some of this cutting edge research and then teach our students what's going on under the hood of these algorithms, right? And so, we always have a lot of fun teaching these classes, so you'll see students like all over this building, for example, because we do a lot of it at MPAC. They're hanging things off the railings and standing all around the place. And so it's a lot of fun to have students make their own creative output by, being clever and fun with their assignments. Here's an example from another course I taught that's more on the generative algorithm side. I assigned them to go out and collect some of their own data from somewhere. And so this student went out and collected leaves from around campus and then built a generative algorithm that can kind of morph between all sorts of reasonable looking leaves that you might find around. And finally, here's an example of a, video. So again, things move very fast. This was done maybe 2 years ago at the time when this technology was very new. Now, of course, we're seeing generative AI videos come out all the time, but I really like the way this looks. There's kind of like this anime kind of foreground, this kind of painterly background. And so the students learn a lot by, applying these, new technologies, taking their own video and making really cool projects and assignments. And so, of course, there's always a lot of outtakes that I keep for posterity of things that didn't work out. So you can learn a lot more about this. I put all my lectures on YouTube, and so if you want to continue your RPI education, feel free to check out the top link, which is my YouTube channel. You can learn more about computational creativity and about visual effects. Rebecca introduced my research. This is not really my research at all. This is something that I just do for fun, but it's great to be at a university where I'm allowed to kind of, take this kind of side project and turn it into classes that I hope the students enjoy. And so that's about it. Thanks very much.